afternoon, everybody. Welcome to Science Access. Today, we continue our differentiation series, part five. Today we be treating graded function. Please, if you know that you are new to this channel, please kindly like and press the notification button so that you get notified when there's upload videos like this. So, in our previous video, I taught some other functions like the polynomial functions, the product function, the quotient function. Today we'll be dealing on the graded function. Now, what is graded function? Graded function, the job of the graded function is to essentially supply us with the nature of gradient of a curve at a particular point. Essentially supply to us the gradient of a curve at a particular point. Now, for example, let's see what is the gradient. The question now, what is the gradient? Y equals sin 6x plus cos x. This question here, like me asking a question now, what is the gradient of this one? Y equals sin 6x plus cos x at a particular point where x equals pi all over 6. Now, dealing with this, first of all, we have to look for the derivative of y. Now, the derivative of y, also known as the y prime, equals, now we differentiate this and this. Now, differentiating sin 6 give us 6 cos 6x. First, we differentiate the 6x before the trig. And differentiating the 6x will give us 6. Differentiating the trig, which is cos. Now, we write what is differentiated with the 6x. And now, moving to this, differentiating cos, differentiating this one, it give us 7. And differentiating cos, it give us negative sign. So, give us now, we now have negative 7 sin 7x. That is it. Now, y prime equals cos 6 cos x. Now, wherever you see x, replace it by this with this one here, pi all over 6. Wherever from here now, wherever you see x, replace it with this pi all over 6. Now we have this x here. Now going to replace it with this pi all over 6. Then you have 7 sin 7 this x, replaces with this one. Y prime equals 6 cos 6. Remember the value for pi is 3.14. Normally, I know that we all know 22 all over 7. 22 all over 7. 22 divided by 7 will give us 3.14. That's how we came about this. 1. Now, pi is 3.14. You can press your calculator as well to verify. And minus 7 sin 7 pi, remember 3.14 all over 6, bracket close. Now y prime equals 6 cos 6, bracket open. Now we use this 3.14 to divide 6. See, 3.14 divided 6 will give us 0.52. Minus 7 sin x, 7 sin 7. Right? Now, the same 3.14 divided 6 will give us 0.52. Rather. Now, y prime equals 6 cos. Now, we use the 6 to multiply this one. So, 6 times 0.5 give it 3. Minus 7 sin. So, we use 7 to multiply this 0.5 will give us 3.5. Y prime equals 6. Cos 3 will give us 0.9986 minus 7 sine 3.5 will give us 0.1. Now y prime equals 6 times 0.9986 will give us 5.9916 minus 7 times 0.1 will give us 0.7. Finally, y prime equals 5.9961 minus 0.7 will give us 5.2916. This is our final answer. This is our final answer. Moving to question 2. Y equals cos 3s. At this question, this y equals cos 3s. At this question, they are telling us to look for the gradient y equals cos 3s at a particular point where x equals pi over 15. Now, using prime, y prime, also known as the y dx, equals differentiating cos 3x. First, remember we differentiate our 3x, use our 3, differentiating the trig, which is the cos, which will give us negative sign minus sign. Now we write what is differentiated, leading to minus 3 sine 3x. Y prime equals minus 3 sine 3. Now, wherever we see x, we replace it with pi all over 15. Now, 3 pi over 15. Y prime equals minus 3 sine 3. Remember that our pi is 3.14 all over 15. Y prime equals minus 3 sine 3. 3.14 divide 15 to give us 0.21. Y prime equals minus 3 sine 3 times 0.21 will give us 0.63. Now, y prime minus 3 sine 0.63 will give us 0.011. Now, y prime equals minus 3 times 0.011 will give us minus 0.033 as our final answer. Question number 3. Y equals sine x. Y equals sine x. The derivative of y is cos s. The derivative of sine x is cos x, where x equals 60. Remember, the y dx equals sine x. The y dx of, the y dx, the variation of y respect to x, will give us cos s, because the derivative of sine is cos. Now, according to the question, where x equals 6 degrees, now y prime equals 60, cos 60. Remember that we have our cos here, right? This one, our cos here. Now our x now is our 60. We take our x as 60, which will give us cos 60. Y prime equals cos 60 will give us 0.5. Therefore, the gradient of y equals sine x at x equals 60 is 0.5. That is it for this question. Question number 4. Find the gradient y equals x raised to the power 3 plus 4x plus 1 at a point where x equals 0. Y prime equals differentiate 3 raised to the power of 3, x raised to the power of 3. Remember, we'll bring the power down, which is our 3. X, remove 1 from the power to give us 2. Plus, the differential form of 4x is 4. Our constant is 0. Y prime equals 3. Now, wherever we see x, replace it with 0. Remember, at the point where x is 0. So our x now will be 0. 3, our bracket open 0, raised to the power of 2, plus 4. Y prime equals 0 squared is 0. 3 times 0 is 0, leaving us with 4. Now, finally, y prime equals 4 as our final answer. Remember, the question under gradient is find the gradient of a particular question at a point where x is so number. Here, our x given here was 0. That is why we had to substitute 0 wherever we see s in this question. Now, question number 5. Y equals 10 cos x. Y equals 10 cos x at a point where x equals 30 degrees. Now, we take the differential form of y. Y prime equals 10. Differentiate cos will give us negative sign minus 10 sin x is the differential form. The differential form of this one is this one, because this 10 is the coefficient of the trig, right? Now differentiating the trig give us negative sign x. That's how we got this value here. Now dy dx, or the y prime rather, equals negative 10 sine our x. Remember, when s is 30 degrees, right? So we replace the x with our 30 given to us. Now, let's be 30 have here. Y prime equals negative 10 sine 30 will give us 0.5. Sine 30 is 0.5. Now we proceed further. Y prime equals negative 10 times 0.5 will give us negative 5. This is the answer for this question. That is all for this question. Mind you that when dealing with graded function, we're talking about curve. Graded function, the job of the graded function is just essentially it tells us the gradient of a curve at a given point, at a particular point where x is, the x can be 90, the x can be 60, depending on the question given to you. After your first differentiation, you plug in the value of x. So that is that for gradient function. So if you have any question relating to this one, or you need area of clarification, you want to be clarified, or you are not, maybe you've been showing question before, you're not sure of your question, you can bring it to our comment section. We will lay emphasis on it and lay it into consideration. Anything at all you can ask pertaining this one or our previous video, we will see to it. Thank you.